A strain is defined as the ratio of any one of the above. Hooke's law holds good up to limit of proportionality. Young's modulus is defined as the ratio of longitudinal stress and longitudinal strain. The unit of Young's modulus is kg per centimeter square. Deformation per unit length in the direction force is known as linear strain. If equal and opposite forces applied to body tends to elongate it, the stress so produced called as tensile stress. The material having same elastic properties in all directions are called as isotropic materials. A thin mild steel wire is loaded by adding loads in equal increments till it breaks. The extension noted with increasing loads will behave under increasing uniformly first and then increase rapidly. This is the figure. Figure means this is the medium carbon steel heat treated. Medium carbon steel heat treated. Figure shows relative opposite graphite of stress and strain for different materials: soft brass, cold rolled steel, and low carbon steel, and medium carbon steel. The heat treated. This is the medium carbon steel heat treated. In above figure, curve B for this is the cold rolled steel. B is the cold rolled steel, and C is the low carbon steel, and C is the low carbon steel, and D is the soft brass, and D is the soft brass. And the modulus of rigidity defined as the ratio of shear stress and shear strain. If the radius of wire stretched by a load is doubled, then its Young's modulus will be Young's modulus will be this remains unaffected. The ultimate tensile stress of mild steel compared to ultimate compressive stress is more. A tensile strength of a material is obtained by dividing the maximum load during the test by the original cross-sectional area. The impact strength of material is an index of its toughness. The Young's modulus of wire is defined as the stress which will increase the length of wire compared to its original length is the same amount. The percentage reduction of area in performing tensile test on a cast iron may be of the order is 0%. The intensity of stress which causes unit strain is called the modulus of elasticity. True stress strain curve for a material is plotted between load instantaneous cross-sectional area and log original area by instantaneous area. During tensile test on a specimen, 1 cm cross-section maximum load is also labeled. For a steel, the ultimate strength shear compared in tension is nearly half. Which of the following has no units? Strain ki no units. Which of the false statement about true stress strain method? It does not exist. A tensile test on a mild steel specimen with breaking stress is compared to ultimate tensile stress is less. If a pot is constrained to move and heated, it will be develop compressive stress. Which of the following material is the most elastic? Steel. The value of modulus of elasticity for a mild steel in the order of 2.1 10 power of 6 kg per centimeter. The value of Poisson ratio for a steel between 0.25 to 0.33. The bulking load for a given material depends upon slenderness ratio, area of cross-section, and modulus of elasticity. The total elongation produced in a bar of uniform section bearing vertically downward due to its own weight is equal to the produced by weight. This is half the weight of bar applied to lower end. The property of material by virtue which body returns to its original shape after removal the load is called as elasticity. The material which exhibits the same elastic properties in all directions are called as isotropic. The value of Poisson's ratio for cast iron is 0.23 to 0.27. The property of material which allows it to be drawn into a smaller section is called a ductility. Poisson's ratio is defined as the ratio of lateral stress and longitudinal stress. Lateral stress and longitudinal. For which all material Poisson's ratio is more than unity. This is the none of the above. The property of material by virtue of which it's beaten or rolled into plates is called as malleability. The change in the unit of volume material under tension with increasing the Poisson ratio will decreases. The percentage of reduction in area cast iron specimen during tensile test would be order of negligible. If a material expands freely due to heating, it will be developed as no stress. In a tensile test near the elastic limit zone, the tensile strain increases more quickly. The stress necessary to initiate yielding is considerably greater than the necessary to continue it. In the tensile test, the phenomenon of slow extension of the material, that is stress increasing with the time at a constant load, is called as creeping. The stress developed in the material not breaking point in extension is called as breaking stress. Rupture stress is the load at breaking point neck area. The elasticity of various material is controlled by stress at elastic limit. The ratio of lateral strain and the linear strain within the elastic limit is known as the Poisson ratio. The ratio of direct stress to the volumetric strain in case of body subjected to green mutual perpendicular stress equal to incidence is equal to dash bulk modulus. The stress at which extension of the material takes place more quickly as compared to the increases in load is called as yielding point of the material. Specimen MS have their lengths diameter L, D, L, 2L, DL, 3L, DL, 4L, DOD, 5L, 5D. Which of the following, which of choose will largest extension when the same extension applied to all of them? This is the first. The percentage reduction in area in case of cast iron when subjected to tensile test of the order of 0%. In compression test, the fraction in cast iron specimen would occur along in oblique plane. The loss of strength in compression due to overloading is known as Boucher effects. The problem. Okay, this is problem. Flow stress corresponds to plastic deformation of solids. When it's indicated that the member of elastic, it means that the means when force is applied, it will stretch. The energy absorbed in a body when it is strained within the elastic limits is known as strain energy. Resilience of material is considered when it is subjected to shock loading. The maximum strain energy that can store in a body is known as proof resilience. The total strain energy stored in a body termed as resilience. Proof resilience per unit volume as a material is known as modulus of resiliency. Strain energy stored in a body volume V stress due to gradually applied load is S square by V 2E. The strain energy stored in a body volume V due to shear stress, shear modulus C is the dash S square V by 2C. The stress induced in the body due to sudden applied load compared when it is applied gradually is the 2 times. The strain energy stored in a body to sudden applied load compared when it is applied gradually is 4 times. A material capable of absorbing large amount of energy before fracture is known as toughness. Coaxing the method of increasing fatigue resistance by over resisting the metal by successively increasing loading. A vertical hanging bar of a length L weight W kg per unit length and carries load W at bottom. The tensile force at distance Y from support in the bar will be W plus W of L minus Y. A beam is loaded and cantilever. If the load at the end is increased, the failure will occur at the support. A non-yielding support implies that the slope of the beam at the support is 0. The ratio of elongation of the prismatic bar due to its own weight compared to another similar by carrying the additional weight it will be 1:3. Stress concentration flat bar having hole radius compared to flat bar having same dimensions but having circular fillets of radius are both ends will be more. The dimensions of Young's modulus of elasticity are given by M1, L minus 1, T minus 2. The yield point of fractional loading as compression yield point is static loading is higher. In prismatic member made up of two material joints, they form equally under axial stress. The unit stress in two materials are proportional to their respective model of elasticity. Moment of inertia of an area will be least with respect to central axis. The distance between the center of two consecutive rivets in the same row is called as pitch. The riveted boiler joints, all stresses, shearing, bearing, and tensile are based on the size of the drilled or remeled hole. The distance between the center of rivets and the adjacent rows zigzag riveted joint is known as the diagonal pitch. Efficiency of riveted joint, the ratio of stress maximum to the strength of the unpunctured plate is tension. When two plates are butt together and riveted with a cover plates with two rows of rivets, the joint is known as double riveted double cover butt joint. Increasing number of rows rivets results in decreasing efficiency of joint depending upon number of rivets used. A riveted joint in which every rivet of row is opposite to the other rivet to the outer row is known as chain riveted joint. A riveted joint in which the number of rivets decreases from the innermost to outermost is called as diamond riveted joint. The diameter rivets in mm for plate thickness T mm taken as 6.05 root T. If the rivets in adjacent rows in the strategy and the outermost row has only one rivet, arrangement of the rivets is called a diamond riveting. Diamond riveted joint can be adapted in the case of following type of joint is the butt joint. Rivets are made up of following type of material ductile. A riveted joint in which sparing rivets is styled such a way that the every rivet in the middle of the two rivets of the opposite row is known as zigzag riveted joint. The weakest section of diamond riveting is the section which passes through the one rivet of the end row. The breadth we plate joint diamond rivets diameter of the efficiency of the joint are given b minus d by b. In case of an eccentric loading in the brake is subject to moment tangential force developed to rivet the tight angle to the radius effect mr by sigma r square. A beam of length L having uniform length W uniform length supported freely at the end of bending moment WL square by 8. Twisting couple in a shaft introduced in its shear stress. The tensile stress in the conical rod having diameter d bottom length W to tensile force distance explained the small end of the dash. 4 f L square by pi of d minus d expressed LD square. LD square. The deformation of a bar under its own weight compared to the deformation of same body subject to direct load equal to weight of the body of the extension of a circular bar having uniform from diameter d1 d2 same of the uniform circular bar of diameter root of d1 d2. The extension of circular ball of length L tapering d1 d2 and subjected to axial pull F is the 4fl by pi e d1 d2. The elongation of a freely hanging uniformly steel rope of its length is doubled will increase the ratio of 4:1. Young's modulus is defined as the ratio of longitudinal stress to longitudinal strain. If the material is loaded beyond yield point stress, it loses its if the all dimensions of prismatic bar increased in the ratio of k:1, the maximum stress reduced in the bar due to its own weight increases in the following way k:1. Modulus of rigidity is defined as the ratio of shear stress to shear strain. A body is subject to three mutual perpendicular stresses equal intensity. The ratio direct stress corresponding volumetric strain is called bulk modulus. A tapered bar of length L diameter d base and having specific weight rho is suspended freely under its own weight. Elongation bar will be PL cubed by 6e. The tapered bar of length L diameter d and ends it is subjected to axial load. Then the elongation producer will be P rho L by pi dd. There are two bars, one prismatic and conical length and weight of ball same. The ratio of their elongation due to their own weights will be 3:1. This is the hardness with respect to Brinell's number. The relationship Rockwell B. Relation between various scales of the hardness with respect to Brinell's number is the Rockwell B. Figure curve B is the Vickers. Curve B is the Vickers and curve C is the scaloscope and curve D is the Rockwell C. A structure made up of several bars joined together is known as frame. A frame in which the number of members is sufficient to keep in equilibrium is known as the perfect frame. The number of members in a perfect frame having j number of joints is equal to 2j minus 3. The force acting along the circumference will cause stress in the wall direction normal to the longitudinal axis cylinder. This stress is called hoop stress. A cylindrical section having no joint is known as a seamless fraction. Longitudinal stress in a thin cylinder. This is the half of the hoop stress. The radius of taken into consideration in a circulation. The stress is hollow shaft. Oblique torsion is the outer radius. Thin cylindrical usually store is the any one of the. The safe twisting moment as compound shaft is equal to the dash. Minimum calculated value. The ratio of maximum shear stress to maximum normal stress at any point is solid circular shaft is the 2. Torsional rigidity of a shaft expressed by the torque required to produce twist to 1 radian per unit length of the shaft. Strain energy stored in a solid circular shaft in a proportional to 1 by Gj. In the case of thick cylinder, 6 cylinder, the ratio of cylinder diameter to wall thickness is less than or equal to 20. If R1, R0 inner and outer cylinder can be applied to R1, R by R0 is equal to greater than 1.2. The value of shear stress which introduced shaft due to applied couple varies from 0 at the center maximum at the circumference. A key is subjected to side pressure as well as shearing force. This pressure are called as bearing pressure. A belt drive, the pulley diameter doubled, the belt tension pulley with the remaining same. The changes required in a key will be dash. Increase key width. Shear stress induced in a shaft subjected to tension. None of the above. In the design of pulley key and shaft, key is made weaker link. A member subject to tensile force F and the normal cross section perpendicular to line force, the resulting normal stress oblique plane inclined at angle transverse plane T by A cos by theta. Above problem, resulting stress oblique plane inclined angle T transverse plane will be P by 2A sin 2 theta. P by 2A sin 2 theta. Mohr circle can be used to determine following stress on inclined surfaces. All of this above. Which of the following constitutions statically determined beams simply support cantilever and overhanging beams? At the principal planes, the normal stress maximum, minimum, and shear stress is 0 of the tensile strength. The longitudinal stress induced in a thin-walled cylindrical vessel is PD by 40. This is the increase. A flat belt filled radius shown in the figure subject to tensile loading. As the H by R increases, the stress concentration factor will be dash increases. H by D increases, the stress concentration factor will be dash decreases. The elongation produced in a tapered shaft with the end of diameter D1 D2 due to tensile compressive axial load is proportional to 1 by D1 D2. This is the som1 figure, variable stress of failure, which is the correct curve, is the curve A. The circumferential stress induced in a thin-walled cylindrical vessel is PD by 2T. The force in the various members of a perfect frame can be found out from any one of the above. The maximum load at which fillet joint length L can be subjected to equal to 0.7 into permissible shear stress into fillet size into L. A large cylindrical vessel was scaled in a summer. What is likely to happen to it in the winter? It is buckle and collapse. Determine the smallest hole that can be punched in a plate of thickness of maximum crushing stress. Punch is 4 times of shear stress plate. T. Pressure were not made of rectangular shape because they are not economic grade. Units of strain are dimensionless. A cylindrical bar of length meters deforms by the strain in a bar of 0.201 L by L. A composite bar of copper steel heated, the ratio of tensile force steel compressive stress in copper will be dash 1. A composite bar made up of steel copper is heated up, the stress developed steel copper will be dash tensile and compressive. The relationship between the modulus of elasticity modulus of G is the G square E by 2 of 1 plus mu. Volumetric strain of rectangular body is subjected to axial force terms of linear strain is Poisson's ratio mu is equal to E of 1 minus 2 mu. A cube is subject to 3 mutual perpendicular tensile stress. The volumetric strain will be 3s by E 1 minus 2 mu. The Poisson's ratio determined by taking readings when load is applied gradually compared to the taken with applied fraction load V dash different to. Bulk modulus K in terms of modulus of ratio E and Poisson's ratio is given equal to E by 3 of 1 minus 2 mu. A solid cube is subject to equal normal forces. The similar nature on our faces ratio volumetric strain, the linear strain in a 3 axis will be dash 3. A structural member subject to an axial compressive force is called a strut. The ratio of shear modulus to the modulus of elasticity Poisson's ratio 0.25 by 0.4. Two solid shafts are made up of same material and their diameter D and D by 2. The ratio of strength of bigger shaft to smaller one. Torsion is 8. The strain energy stored in a hollow shaft of outer and inner diameter D and is subjected to shear stress having modulus of C is equal to dash S square by 4 so D square minus D square by D into volume. Compare the strength of solid and hollow shaft both having outside in diameter D having inside diameter 2 by 2 torsion. Ratio strength solid hollow shaft torsion will be dash 15 by 16. Torsion bars are series, same torque acts in each. The torsional rigidity of a solid circular shaft diameter D proportional to D power 4. The ratio of maximum shear stress to average shear stress in case of circular bar beam transmitting power is equal to 4 by 3. The ratio of maximum shear stress to average shear stress in the rectangular beam subject to torsion is 3 by 2. The elongation of a closed coiled helical spring is subjected to tensile load is proportional to mean diameter of spring. The minimum thickness of flange plated at the center shaft determined by the fact that there must be sufficient prevent shaft shearing from the flange of the cylindrical surfaces. Compression member tends to buckle in the direction of least radius of gyration. Moment of inertia of an area always least with respect to centroidal axis. Torsion bars are parallel if they have equal angles in the applied torque torsion between them. When the external forces moment and support an object can be found, the equation along subject to be statically determined. The reaction of each support beam can be determined from following additional equilibrium, all of the above. Section modulus Z is expressed as I by Y. The section modulus of circular section about an axis through its center of gravity, pi d cube by 32. In section modulus of beam increases, then bending stress will be dash increases. For given stress ratio of moment of resistance square beam with its sides horizontal compared to when diagonal horizontal is root 2. The moment of diagram of cantilever beam subjected to bending moment at the end of beam will be rectangular. The load at free end of cantilever increases to it cause rupture save will occur at fixed end. This is the D etla. Central load subject to family bending moment diagram from shown in the figure A, B, C, D are below. This is the D. Shear force at any point at the beam or the algebraic sum of dash forces on either side of the point. Bending moment at any point is equal to the algebraic sum of a moment of force on either side of the point. The rate of change of shearing force at any section equal to the rate of loading at the section. Two equal length beams fixed their ends, carriage distributed and other care same load but concentrated. The middle the ratio of maximum deflection will be dash root 2. Thank you. Strength of material first.